Okay guys, welcome back. We're going to wrap it up here with three additional examples. The first one, example 4, again, the trig is not going to be hard. It's just a little bit different approach to solving it with the algebra. So first thing we're going to do, isolate your sine x. So I'm going to add 3 to both sides. 4 sine squared x equals 3. Let's divide by 4. Sine squared x equals 3/4. Now we're going to use the square root method here. So basically I'm going to take the square root of both sides, because if I take the square root of sine squared x, that just gives me sine x. But don't forget, when you solve an equation by taking the square root, you get a plus or minus. I can't take the square root of 3, so I'm just going to leave that square root of 3, but the square root of 4 is 2. So what I have now is a trig equation where sine of x equals plus or minus square root 3 over 2. Well, this is actually going to be a little bit easier than what we're dealing with, than we usually deal with, because where's sine positive or negative? Well, every quadrant. So now I just have to list all the angles from negative 2 pi to 2 pi in every quadrant where sine of x is square root 3 over 2. Well, we've got to know where sine is square root 3 over 2. That's going to be 60 degrees. So that's going to be pi over 3. So now it's basically just an exercise in your radian families. I've got pi over 3 in the first quadrant. I've got 2 pi over 3 in the second. I've got 4 pi over 3 in the third, and I've got 5 pi over 3 in the fourth. Well, that's from 0 to 2 pi. If you go in the negative direction, basically you just negate all of these. So all I have to do is add a plus or minus to each one of these. And there's my solution. Okay, and our last 2 examples here involve trig substitution. So if you notice example 5, we've got a sine and we have a cosine. And a couple examples ago, I solved an equation that had, I believe it was a tangent and a cosine. Well, this is a little bit different because I can't take out a GCF here. So one thing that we're going to have to do, whenever we have a cosine squared with a sine or a sine squared with a cosine, is we have to use our Pythagorean identity. And you always replace the squared term. You cannot replace a cosine with anything. So if you remember, sine squared is equal to 1 minus cosine squared. Okay, so now at least everything's in terms of cosine. So what I want to do is get everything to one side. And I'm probably going to move the stuff on the left to the right side because I want my cosine squared to be positive. So let's add cosine squared x to both sides. And let's subtract 1. Okay, so now I've got this. This is a quadratic. I'm not going to do the variable equation that's similar to this. At this point, we just need to know how to factor this. So cosine squared x would give you a cosine x and a cosine x. Factors of 2 are just 1 and 2. That's easy. Signs are going to be different, and you need a negative middle term. So the 2 is going to be negative, and the 1 is going to be positive. So now once you have your factors, let's set each one equal to 0 and solve for cosine x. Cosine x equals negative 1. And over here, cosine x equals positive 2. Well, anytime I see a value with cosine or sine that's above 1 or below a negative 1, I know that that can't exist, so there's no solution from this particular equation. Over here, cosine x is negative 1. Well, I'm thinking unit circle. Cosine is the x value. Where is the x value negative 1? Right there. So now I need to consider my domain. It says 0 to 4 pi. So here's what I'm doing. There's 2 pi, and there's 4 pi. All right, this angle right here is 180 degrees, which is pi. So my solution is going to be pi, and then I need a coterminal angle. I mean, you can just keep counting as you go around the unit circle, or find a coterminal, you just simply add 2 pi to it, and there's your solution. Okay, our final example, and probably the most challenging one. 2 cosine squared x equals 1 minus sine x. So again, I see a cosine squared, I see a sine. I have to replace the cosine squared. Now be careful because this one has a leading coefficient of a 2. So I'm going to leave the 2, but I'm going to replace cosine squared with 1 minus sine squared x. And now what I'm going to do is distribute. So I've got 2 minus 2 sine squared x equals 1 minus sine x. And like I did up above, I want to move the negative 2 sine squared x to the right side. So I'm going to add that. I've got minus sine x. I'm going to subtract 2. So I've got 1 minus 2. That's going to give me a negative 1. And that becomes a 0. So now no GCF here. I wish I could divide off of 2, but I can't. So I'm just going to have to factor this with a leading coefficient. Well, it's really not that bad. That's going to be 2 sine x and sine x. Factors of 1 are just 1 and 1. Signs are different. Your middle term is negative, so you have to multiply the 2 times the negative 1, and then that's going to be positive. Okay, so what does that give us? From this factor here, sine x equals negative 1 over 2. And then from here, sine x equals 1. Well, I'm going to do this one first because 1 is a unit circle. I happen to think those are a little bit easier. But again, 0 to 4 pi, so it's going to be a bit of work. Sine x, sine is the y value. So where is the y value 1? Right here. I need to go from 0 to 4 pi. So basically I'm going around twice. Okay? That's going to hit pi over 2. And you can count it out if you want, or just add 2 pi to it. So you can add 4 pi over 2. Okay? So that's going to be 5 pi over 2. Now, where's sine x at negative 1/2? Well, if you talk about quadrants, ASTC, where is sine negative? Sine is negative in the third and the fourth. The reference angle where sine is 1/2 is 30 degrees, so that's pi over 6. So here's where it gets a little bit challenging. Pi over 6 in the third quadrant is going to be 7 pi over 6, so that's going to be part of our solution. And in the fourth quadrant is going to be 11 pi over 6. Well, that's great if we just go from 0 to 2 pi, but we have to add 2 pi because I need coterminal angles. Because if you remember, we're going from 0 to 4 pi. So basically over in this situation, there's 0 to 2 pi, and then you go around one more time. So what I'm going to do to each of these, since I have to add 2 pi, that's the equivalent of adding 12 pi over 6 to both of them. So 12 pi plus 7 pi is going to be 19 pi over 6, and then 12 pi plus 11 pi is going to be 23 pi over 6. So our solution for this equation would be those 6 angles. Okay? So that wraps up the notes, guys, for Unit 10. Please do all the homeworks. Check your answers with the homework keys. We've got work sessions on there, the review, and all those keys as well. And again, please don't hesitate to contact us via email or Schoology if you have any questions.